Dear students, today's topic is momentum. Class 9, ninth subject physics. Momentum. Linear momentum. You have to study about linear momentum. First of all, we are going to define momentum. What is momentum? The product of the mass of a body and its velocity at any instant is called its momentum at the particular instant. You can simply define momentum as the product of mass and velocity of a body. It is a vector quantity. Its SI unit is kg meter per second or kg meter s to the power minus 1. It is denoted by P, a small p. Momentum equals to mass into velocity. P equals to mv. This arrow sign shows that momentum is a vector quantity. Velocity is also a vector quantity, as you know. Mass is a scalar quantity. Here momentum is the product of mass and velocity. As you know, mass is a scalar quantity and momentum is a vector quantity. And you also know that the product of a scalar quantity and a vector quantity is always vector. It has magnitude as well as direction. The direction of the momentum of a body is the direction of the velocity at the particular instant. And you also know that the SI unit of mass is kg and that of momentum is velocity is meter per second. So the SI unit of momentum is kg meter per second or kg meter second to the power minus 1. change in momentum. Change in momentum equals to final momentum minus initial momentum. Change in momentum is represented as delta P, final momentum Pf, initial momentum Pi. F stands for final, I stands for initial. Change in momentum is equal to final momentum minus initial momentum. Question is that which is responsible for change in momentum of a body? This is force. This is an unbalanced force. When you apply an unbalanced force on a body, its momentum changes. Take an example. Suppose a body is moving in a straight line. You have to study about linear momentum. Momentum change, product of mass and velocity in a straight line. I mean to say that the object does not change its direction of motion. It changes only its magnitude. At point A, there is an object whose mass is m and initial velocity is 0. It means it is at rest at point A at time t equal to 0. After 1 second, suppose you can take m is equals to 2 kg or 3 kg or 5 kg, 2 kg. At point A, the momentum of the body is PA. PA means momentum at point A when time is 0. mu, that is 0. At point B, after 1 second, its velocity increases by 2 meters per second. It means at point B, the velocity of the object is 2 meters per second. Now PB equals to mass remains constant 2 kg. So mass into mass into velocity at that point 2 into 2, 4 kg meter per second. At point C, mass remains constant 2 kg, time 3 seconds, u2, velocity after 3 seconds. You can take 4 meters per second. At that point, the momentum is mass into velocity 2 into 4, 8 kg meter per second. you observe that when the body moving along the line AC from A to C, the velocity of the body increases, and you also see that the momentum of the body increases. At point A, it is to 0 kg meter per second. At point B, it is 4 kg meter per second, and at point C, it is 8 kg meter per second. There is change in velocity, and you also know that force is the factor that can change in the velocity, in the position, in the shape of an object. So I mean to say that only force can change the momentum of a body. One thing I would like to say here, as you know, mass is the measure of inertia. Mass is the measure of inertia. Likewise, momentum is the measure of motion. Momentum is the measure of motion. Mass is the measure of inertia. Inertia, momentum is the measure of motion. If you draw a graph between momentum and velocity of a body, you will get a straight line. Take momentum along y-axis, velocity along x-axis. Suppose the mass of the body is 2 kg. At time 0, the velocity is 2 meter per second. 2 meter per second. Then 2 to the 4. Momentum will be 4 kg meter per second. After some time, its velocity is 3 meter per second. Its momentum is 3 to the 6 meter per second. After some time, its velocity is 4 meter per second. Then its momentum is 4 to the 8 kg meter per second, and you get a straight line. This shows that momentum is directly proportional to velocity if mass is constant. If mass is constant. And the slope of this momentum velocity graph gives mass. P equals to m into v. This is the basic formula of momentum. Now you can write mass equals to momentum by velocity. Thank you. In the coming lecture, you will solve some new numericals related to momentum. Thank you.